Section 2.3 is on volume, which is the amount of three-dimensional space that an object occupies. I mean, I have a hard time drawing in 2 dimensions. 3 dimensions is almost impossible for me. So let me try to explain what volume is by looking at this diagram. So this diagram is kind of a box in some sort. We might call it a rectangular prism in this section. And what I tried to do is find a picture that showed volume, decently anyways, and each one of these boxes that make up this diagram is going to be 1 cubic centimeter, because each one of these boxes is going to be 1 centimeter by 1 centimeter by 1 centimeter. There's 1, 2, 3, 4, 5 boxes going vertically because it's 5 centimeters tall. There are 1, 2, 3 boxes going horizontally, I guess, because it's 3 centimeters wide, for lack of a better term, and 4 boxes going in this direction. I'm not going to attempt to name that right now. And so each one of these boxes is 1 by 1 by 1. Each one of these boxes is 1 cubic centimeter. The volume of this three-dimensional box is the number of these 1 cubic centimeter boxes that would take to construct it. And I can real easily figure out how many boxes there are by just multiplying here the 5 times 3. Each one of these from here to here each one of these kind of columns has 15 boxes, which would mean it has 15 cubic centimeters, and there's 1, 2, 3, 4 of these columns. So there's going to be 4 columns that each have 15 cubic centimeter boxes in it, and 15 times 4 is 60. The nice way to figure out the volume of this object is just to multiply each of the dimensions, to multiply the 5 centimeters times the 3 centimeters that you can barely see anymore because I covered it up, times the 4 centimeters. If you multiply 5 times 3 times 4, that gives me the number of boxes. The 5 times 3 gives me the 15 boxes in each column, and then there's 4 different columns. And 5 times 3 times 4 is going to give me the 60 boxes that make up this object. And when you multiply centimeters times centimeters times centimeters, you get cubic centimeters. And I can write the word cubic centimeters, or I could write a symbol that means cubic centimeters. I took the centimeters and put a little exponent of 3. This box has a volume of 60 cubic centimeters. In this section, we're going to be finding the volume of just common geometric shapes, and you don't have to have the formulas memorized. As we go to find the volumes, I'm just going to keep pulling back to my sheet of formulas. You are going to need to know what the shapes are called so that you can reference the right formula. And the common shapes that we're going to deal with, a cube is just a box where all the sides are the same length. It's kind of like a dice in some sense. The box that I had on the last page was called a rectangular prism. It is essentially a box where all the sides are made up of rectangles. There's a top rectangle and a rectangle there. Every side is a rectangle. That makes it a rectangular prism. This is supposed to be like a soccer ball or a basketball. A three-dimensional ball is a sphere. This is like a Coke can here. A right circular cylinder is essentially a round can. A right circular cone is just what I think of as a cone. It comes to a point. A right square pyramid. Pyramids come to a point, and this pyramid has a square base. That's why it's called a square pyramid. We have pyramids that aren't square pyramids. This is a rectangular pyramid. It's a pyramid because it comes to a point, and it's a rectangular pyramid because the base of the pyramid is a rectangle as opposed to a square pyramid. And We have prisms. This is a triangular prism. Pyramids, they come to a point. Prisms you can look through. And this prism is considered a triangular prism because when I look through it, I'm looking through triangles, for what that's worth. So these are the common shapes that we're going to be dealing with. And every time I ask you to find a volume of a shape, I'm going to pull back this sheet and try to reference this sheet to give you an idea of what the shape is. So, first example that I wanted to do, I need to find the volume of that shape, and it comes to a point, so it's some sort of pyramid, and I have two different pyramid formulas. I have this right square pyramid where the base is a square, and I have a rectangular pyramid where the base is a rectangle. This is a rectangular pyramid because the base is a rectangle. So in order to find the volume, I needed to know the shape of this, which is a rectangular pyramid, and the formula I'm going to use is 1/3 times the length times the width times the height. Technically, when you go to find the volume of a pyramid, it's 1/3 the area of the base times the height. This big B here means the area of the base, but the base is a rectangle and the area of a rectangle is length times width. So this formula says the volume is 1/3 B times the H. B is the area of the base. The base is a rectangular bottom, and that has an area of length times width. So to find the volume of this pyramid, I'm going to just use the formula. I'm going to go volume equals 1/3, and then the length times the width come from the rectangular base. Usually when I go to assign lengths and widths in a rectangle, I make the length the longer one and the width the shorter of the two. The rectangular base, I'll say, has a length of 8 inches, a width of 7 inches, and the last dimension I need is the height. The height is the distance from the very top of the pyramid to the base, and that line actually has to form a right angle, and in this case the height is going to be 6 inches. So if I wanted to do this computation and I'm not feeling that motivated this morning, I could use my calculator to do this all. So to find out the volume without doing any sort of computation in my head, I'm going to enter each of these numbers in a parentheses. I'm going to do 1 divided by 3 for 1/3, 8, 7, and 6. And my calculator is going to give me V for volume. It's going to give me the number, and I'm going to have to get the units here in a second. So the volume of this pyramid is 112, and my units, I'm going to multiply the inches times the inches times inches, and I'm going to get cubic inches. I almost always write a symbol instead of a word when I do volume, and the symbol that I might write there is inches cubed, and that's how I'd find the volume of this pyramid. And you'll see my answer perfectly is there. If I wanted to do this multiplication by hand, what I would do is I would have taken this 3, canceled with that 6, and made it a 2. Then I would have multiplied 8 times 7, which is 56, and then 56 times 2 would give me the 112. I don't need to see any of the arithmetic or to get the numbers. If you want to punch them in your calculator, that's fine. Alright, so the next shape I want to find the volume for is clearly a prism because I can look through it. And then in the world of prisms, on our formulas, we have the box that's a rectangular prism because all the sides are rectangles. And we have this lovely triangular prism, and this is going to be a triangular prism, and it's really a rough formula here. You can barely see it. In this formula, in the triangular part, the area of a triangle is the base times the height over 2, and the triangle part, there's a base and a height, and then the rectangle part of it, you need a length. And the volume for a triangular prism is half the base times the height, which is the area of the triangle, times the length from the rectangle. So my volume, in case it's not that readable, is 1/2, or I could say just base times height over 2, which is the area of the triangle, times the length, which comes from the rectangle. the formula here, half the base times the height times the length is equal. That 1/2 doesn't have to be written like, it can be written like that or like that. So let me try to do this now. So I know the volume formula is the base times the height over 2 times the length. And so for this problem, the base is going to be from the triangle, which is the 15. The height's from the triangle, which is the 8. And the length is from the rectangle. So my volume is going to be 15 centimeters times 8 centimeters over 2 times 12. Notice I didn't sneak the units in. This is because I know what the units are going to be. The units are going to be cubic centimeters, and I don't need to write those. When I do this on my calculator, I'm going to be lazy, and I'm going to do the division last. I'm going to go 15 times 8 times 12, and then divide it by 2 very last. So 15 times 8 times 12 divided by 2. Notice I got lazy and didn't write parentheses, and I used time signs. That's completely fine. The number here I'm going to get is 720 for the cubic centimeters. If I wanted to, I could have divided this 8 by 2 and gotten a 4. And this did 15 times 4 times 12. And if I had done 15 times 4 times 12, I'd still get the same 720 for the numerical part of the volume. Another example. Now I look at this. This has a round base, and once we have a round base, even though it comes to a point, we're not going to call it a pyramid. A pyramid, the base is going to be not round. So if I go to look at my formulas, this is a cone. The formula for a cone is 1/3 times pi r squared h, and let me try to just write the formula down here and explain what the pieces mean if it's not obvious. So you don't have to have any of these formulas memorized, so I'll give them to you on the test. Well, there's only 2 numbers labeled in the cone. One of the numbers, the 5.7 centimeters, is on the base, and it's a radius of the circular base, so that must be the r, which stands for radius. The height is the distance from the top of the cone to the, I'll say, center of the base, and it forms a right angle, so the 12 is going to be the height. If I want to, I can leave the units out and just put the units in my answer. I absolutely have to have units in my answer, but I don't have to show units in my work if I know what the units ultimately are going to be. I would absolutely do this on my calculator, and the instructions say find the volume. It didn't say anything about plugging 3.14 in for pi, so when I go to write my answer, I'm just going to leave that pi as part of my answer. I'm going to write my units, which are cubic centimeters, and on my calculator, I need to do this part. I need to do the fraction 1/3, which I'm going to enter in a parentheses on my calculator. I need to multiply that by 5.7 squared, which I'm going to do in a parentheses on my calculator, and multiply by 12. When my calculator gives me a number, I might have to round it. The instructions didn't say anything about rounding, so we'll see what happens when I get this done on my calculator. So 1 divided by 3 in a parentheses, parentheses 5.7, close out the parentheses, hit the x squared key, and then parentheses 12. I see 129.96, and the funny thing is, I wrote 22.8 here, and I don't know what's going on. Let me, you can't see what I wrote, but let me write that down. 129.96, I feel pretty good about that. Let me do this slower. 5.7 squared, 32.49 times 12, and then 389.88 times 1 divided by 3. Yeah, it should be 129.96 cubic centimeters. On this sheet here, I have a mistake. This is a tough problem for a lot of students because it's an odd shape. This figure has a cone in it, but it's not just a cone. It's a blending of two shapes. So the shape that I'm going to worry about here, this object, the base, the bottom of it, is a cone. And I'm going to need to find the volume of the bottom separately from the volume of the top. The top isn't supposed to be a full sphere or a full something like a soccer ball. This is a half a soccer ball, or a half a sphere. In order to find the volume of the shape, I need to find each of the volumes separately. And when I find the volume of the sphere, I need to find half of it. So first formula I'm going to get is for the volume of the top, which is the sphere. The volume of the sphere would be 4/3 pi r cubed. I'm going to multiply that by 1/2 because I only need to find a volume of a half a sphere because that's all I have. The cone is the 1/3 pi r squared h. Each one of these volumes is going to, the units are going to be cubic centimeters, and after I find the volume of each, I'll add them together. So let me do the top first, the sphere, and in the sphere, other than the pi, there's only one number, it's an r, and for this orange sphere, the r is going to be 4 centimeters. So when I do the sphere, I'm going to say volume equals 1/2, because I'm doing half a sphere, times 4/3 from the formula, times pi from the formula, times the radius cubed, which is going to be 4 cubed. I'm going to do this all on my calculator. I'm going to leave the pi in the formula and not use it on my calculator. So let me do this on my calculator quickly and see what happens. So on my calculator, I'm going to go 1 divided by 2 in a parentheses for the 1/2, and then 4 divided by 3 in parentheses. I'm going to skip the pi and then parentheses 4 and then this button under the clear for the exponent 3. Gives me 42 point a lot of 6s. I didn't say in my instructions whether to round to 2 decimals or not. I'll teach you a trick real quickly on this calculator if you don't know it already. If you want a fraction answer, you can get a fraction answer from a decimal answer by hitting the math button and then hitting the enter key twice. So let me make a nice fraction answer here. So I'm going to go math, enter, enter. And I'm going to say the volume of this is 128 over 3 pi, and then the units are going to be cubic centimeters. So that's the volume of the spherical top. If you wrote 42.67 because it didn't say anything about rounding to 2 decimals, I'd live with it, but I just wanted to show you how to do fractions on your calculator anyways, and it's a nice answer. So for the cone, I know the formula has a 1/3 and a pi. The top of the cone is still the circle, and the circle has a radius of 4. So in for that r, I'm going to plug 4 squared, and in for the height, that's the distance from the tip to the circle, is going to be 10. So for my cone, I'm going to leave the volume with the pi, and let me get the number. And I'm going to get the number by putting the 1/3 in a parentheses, and then the 4 squared in a parentheses, and then the 10 in a parentheses. If I wrote 53.33, I could live with that. Let me hit math and enter twice to make it a lovely fraction. So I found the volume of the top separately from the volume of the bottom. The total volume of the shape, and that the answer to this I get by taking the 128 over 3 pi cubic centimeters, 128 over 3 pi cubic centimeters, plus the 160 over 3 pi cubic centimeters. The answer to the total volume of this shape is going to be cubic centimeters for the units. It's going to have a pi in it, And to get the number, if I want a number to go in front of the pi, I'm going to add these two fractions. I'm going to go 128 divided by 3 plus 160 divided by 3. The pi is just going to stay just like an x would stay. Like if you're adding 5x and 3x, you get 8x. The same thing when you're adding with pi, it doesn't change. So I'm just going to add the fractions in front, and when I hit enter, it gives me a lovely number. The volume of the shape that we have here is 96 pi cubic centimeters. All right, time to get into the homework. 30 homework problems. You keep the answers handy. Actually, there's 31 problems. I should say problems 1 through 31, apparently. So, first shapes. Those are prisms, because I can look through them. And they're rectangular prisms, and the volume is going to be length times width times height. The length times width comes from a rectangle, one of the rectangles. So these are rectangular prisms. The volume formula is length times width times height. For me, I'm going to choose this rectangle for the length and the width, specifically because it has, that rectangle has two sides mentioned. I'm going to make the length the longer, the width the shorter, and all of a sudden that forces this to be the third dimension height. Your prism has two sides labeled here, 4.0 centimeters and 9.0 centimeters. I'd probably call that the length and the width. I'll make the length the longer, the width the shorter. This length, which is, if you can't read it, 5.4 centimeters, I would call the height for yours. Ultimately, when you're finding the volume of a rectangular prism, you're just multiplying the three different lengths together. So for me, I'm going to go length, which is 3 centimeters, times width, which is 2 centimeters, times height, which is 10 centimeters. The number is going to be 60. My units is going to be cubic centimeters. That would be the answer to problem 2. For your number 1, I left the answer in a decimal because all the numbers were given as decimals anyways. So I'll walk through 3 with you just in case you need the help. It's another rectangular prism. Same deal here. I'm going to call these the length and the width. I'm going to call the longer one the length, the shorter one the width. It's a rectangle that I have 2 of the sides for. This I'm going to call the height. I'm using the volume of a rectangular prism, which is length times width times height. I'm going to keep the units out until I write my answer. So the length is 3, the width is 2, the height is 6. I'm going to multiply 3 times 2 is 6, 6 times 6 is 36. The number I'm going to get is 36. The units are going to be cubic feet. Go ahead and check problem 3. That's exactly what I have for problem 3. Problems 5 and 6 are right circular cylinders or Coke cans. The volume formula is pi r squared h. And again, you're going to be given at least a listing of formulas, maybe not with the picture attached. Because it doesn't say anything about rounding pi to 3.14, I'm going to leave the pi symbol in. And it should be easy to figure out the r and the h here. The r comes from the radius, which is from the circular top or circular bottom. The h comes from the dimension, the length between the sides. For mine, I'm going to say volume equals pi times 2 squared times 4. I'm going to leave the pi in my answer. I'm going to do the exponent first. Now I'm going to multiply the 4s and leave the pi last. And when I go to write my answer to problem 6, I'd probably say the volume is 16 pi. The units are going to be cubic centimeters. For your problem 5, if you can't read the dimensions here, this radius is 4 centimeters and the height is 12 centimeters. And for number 5, you're trying to get 192 pi cubic centimeters. So if you're trying to do number 7, it's another Coke can, so its volume is going to be pi r squared h. The h will be this 1.8 feet, but the r is not going to be that 3.2 feet. That's a diameter. I need to divide that 3.2 by 2 to get a radius. And so you have to know that the radius is 1.6 feet. So if I was doing problem 7, I'd go volume equals pi times r squared, which is 1.6 squared, times the height. The instructions for this just said find the volume. They were all, for all 30 problems, it was find the volume. I'm going to leave the pi in my answer because nowhere did it say use 3.14 for pi. My units are going to be cubic feet. And because the original problem has decimals, I'm happy with a decimal answer. I don't need to convert the decimal into a fraction. It doesn't say anything in my instructions about rounding to 2 decimals, which I almost always put in. I kind of feel like I should have put it in, but I didn't. So when I go to write the number part of my answer, or the rest of my answer, I'm going to do that multiplication of 1.6 squared times 1.8. I get 4.608. If you wrote 4.61, because you instinctively rounded to 2 decimals, because that's what I almost always do, I completely, if that was a test question, live with it. I think I should have said something about rounding, but because I didn't say anything about rounding when I wrote my answer, I gave all 3 decimals. But I'm not going to be upset if you round to 2 decimals just instinctively. 9's an ugly problem. 9, I should do 9 because 9's a lot harder than 10. So 9 is a cone, and the volume is 1/3 pi r squared h. So the formula I'm going to need is volume equals 1/3 pi r squared h. The h is the distance from the top of the cone to the center of the circular base. The height, should I say, is going to be 8. Unfortunately, I don't know the radius. The radius is the distance from the center of the circle to the side. The radius is right there. And in order to get the radius, I need to use the Pythagorean theorem, because in this figure, there's a triangle that's kind of drawn out. The triangle that's drawn, that I just highlighted in pink, is this triangle. It has the height of 8 meters, which is a number that I need in the formula. It has another number that I don't need in the volume formula, but I need it to get the radius. So that pink triangle that I just sketched out, I brought it and drew it down here. I'm going to use the Pythagorean theorem, the a squared plus b squared equals c squared, to figure out what the radius is. So I'm going to go r squared plus 8 squared equals 10 squared. This is going to give me r squared plus 64 equals 100. I'm going to minus 64 from both sides. It's going to give me r squared equals 36. And then I'm going to square root both sides. And I'm going to get r equal to 6. So when I go to do my volume, I had to have the height, which is the distance from the top of the cone to the center of the circle. I needed to have the radius, which is the distance from the center of the circle to the side of the base. And in this formula, I'm going to use for the height 8, and I'm going to use for the r 6. I'm going to leave pi in my answer because nowhere in the instructions does it say anything about making pi equal to 3.14. When I go to write my answer, my units need to be cubic meters because volume, the units are always cubic. I need to leave that pi in my answer, and then I just need to multiply these numbers out. So 1/3 in a parentheses, 6 squared in a parentheses, and 8 in a parentheses would be a safe way to get the number that goes in front of that pi. So let me try to do that real quickly here. So 1 divided by 3 times 6 squared times 8. And when I do that, I get the number that goes in front, which is 96. So I'm going to say the volume, or the answer for problem 9, is 96 pi cubic centimeters, and that's exactly what I have. Again, I don't know how to make these figures myself, so I just scour the internet to find drawings. Your drawing for problem 11 is another cone, and the height is supposed to be 20 centimeters, and the radius is supposed to be 12 centimeters. And the volume formula for a cone, we just did one, is 1/3 pi r squared h. I'm going to do my cone off to the side here, and yours is nice because it doesn't come out to have a decimal answer. Mine is going to come out to have a decimal answer, which I could make into a fraction. So I'm going to go volume equals 1/3 pi. In for my r, I'm going to take the radius part of this, which is in the circular base. My radius is going to be 8 centimeters, and I need the height. When I go to do my answer, I'm going to leave the pi in my answer. My units are going to be cubic centimeters, and then I'm going to try to get this number nailed down. So this number is going to be found by taking 1/3 times 8 squared times 18. It doesn't say in the instructions to round to 2 decimals. I guess I don't need to. How lovely. I thought I was going to get an ugly decimal, but I wasn't thinking clearly. You're definitely not going to get a decimal for number 11. In number 11, the answer is supposed to be 960 pi cubic centimeters. For 13 and 14, these come to a point. They're not going to be a cone because the base isn't a circle. These are pyramids, and I'm assuming because only one of the lengths of the base is indicated on yours, that it's a square pyramid. And the volume formula for a square pyramid is 1/3 times the s squared, and the s is the length of the square sides, the sides of the square, times the height. So the formula I'm going to need is volume equals 1/3 s squared times h, and hopefully it's obvious what the s's and the h's are. More obvious on yours than mine. Mine is sneaky. It has the height written with a dashed line, and my height is going to be 7. This length, the other length, is kind of the length down the side. This I don't need for the formula. I need the height, which is internal, and this 7.28 is supposed to be going along the outside of the pyramid, and I don't need that in the formula. For me, my height is going to be 7. My height is going to be 7, and my square base is going to give me the s, which is going to be 4. I'm going to assume my units are in meters, and finally, round to 2 decimals. Your answer says leaves in a fraction. For my formula, I'd go volume equals 1/3 times 4 squared times 7. For yours, the height is going to be 7 meters. The side is going to be 5 meters. Let me go through yours with you. So for yours, you're going to go volume equals 1/3 times 5 squared times h. I know in my answer, my units are going to be cubic meters. I have no desire to do that by hand. My calculator would give me a fraction faster and more accurate than I can. So I'm going to go 1/3 times 5 squared times 7. Because it says leave my answer in a fraction, I would probably not want 58.33. Again, to get a decimal into a fraction on this calculator, you hit the math button, and you hit enter once and enter twice. So I'm going to get 175/3 for the numerical part of my volume, and the rest of it's going to be meters cubed. And when I look at my work for problem 13, I get that 175/3. I'm not even going to, well, let me do mine real quickly. On mine, I'm allowed to round to 2 decimals. On mine, I'm going to go 1 divided by 3 times 4 squared times 7. And that rounded to 2 decimals is just going to be 37.33. Assume my units are in meters, so cubic meters. We get another square pyramid, and the formula for the square pyramid's volume is 1/3 times s squared times h. Both of our formulas, it's going to come out so we don't have a fraction or a decimal. It's going to come out nice. For my formula in problem 16, I'm going to make the s the 10 and the h the 18, and I'm going to say volume is 1/3 times 10 squared times 18. If you like doing the numbers by hand, be my guest. I don't care to do them by hand, so I just press buttons. If you have a different calculator, that's fine for this chapter as long as you can do the fractions on it if you want to do the fractions on it. You're more than welcome to do all the algebra here or arithmetic by hand. For problem 15, your answer is supposed to be 48 cubic centimeters. 17 and 18 are rectangular pyramids. They're pyramids because they come to a point. They're rectangular because the base is a rectangle. And my formula is going to be 1/3 the length times the width times the height. So this formula should be volume is 1/3 the area of the base, which is length times the width, times the height. That's the formula that I'm going to use when I go to find the volume. And for both of us, it's going to come out to a nice number. For my length, I'm going to use the 8 centimeters because it's the rectangular base, it's the longer part. For my width, I'm going to use the 6, and for my height, I'm going to use the 5. For you, your height is going to be 6, your length is going to be 8, your width is going to be 7. For me, I'm going to say the volume is 1/3, the length is 8 centimeters, the width is 6 centimeters, the height is 5 centimeters. I could do that in my head, that's not so impressive. So 1/3 times 8 times 6 times 5. My volume, the number part is going to be 80. The units are going to be cubic centimeters. If you don't get the right units on the test, you're going to start losing points that you don't really need to lose. Apparently, for number 17, the answer is 112 inches cubed. We're asked to find the volume of these spheres. And for your sphere, it gives you the diameter. I don't know how readable that is 28 meters. We need a radius to find a sphere. Half of the diameter is a radius. My sphere has a diameter of 7 meters. A radius is going to be half of that, or 7/2 meters. And both of our problems say leave your answer as a fraction and leave the pi in your answer. I need to have this formula before I can do this. And the volume of a sphere is 4/3 pi r cubed. For mine, it's ugly. Mine's going to be, the volume is going to be 4/3 times pi times 7/2 cubed. When I go to write my answer, I'm going to leave the pi in my answer because I'm asked to leave it in terms of pi. My units are going to be cubic meters. And then on my calculator, I need to push through this. I'm going to put the 4/3 in a parentheses with no exponent outside of it. I'm going to put the 7/2 in a parentheses, and then I'm going to exponent 3 outside of it. It's going to give me a decimal. I'm going to hit the math button followed by enter twice to get the fraction that goes in front of the pi meters cubes. For 20, that would be the volume. For 19, I got this ugly 10,976 over 3 pi meters cubed for your sphere. Let's do, well, heck, you could do 21. I'm going to do 22. The radius is 14 centimeters, just in case you can't read it in yours because it's too small. The radius is 2 centimeters. Again, the volume formula is 4/3 pi r cubed. I'm leaving my answer as a fraction, and I'm leaving pi in my answer. So I'm going to go 4/3 times pi times 14 cubed, and break out my calculator. So 4 divided by 3 times 14 exponent 3, math, enter, enter. Hey, so that's the number you had last time. So I get 10,976 over 3 pi, and then centimeters cubed. And for year 21, I got 32 over 3 pi inches cubed. Let me do 23 with you, which is a little bit harder than 24. So I need to find the volume of this combined shape. We did a combined shape like this already. We have an upside down ice cream cone, and I need to find the volume of a cone and a half a soccer ball or a half a sphere. So I need both of those formulas. The cone, the volume formula for it is 1/3 pi r squared h, and the sphere, the volume formula is 4/3 pi r cubed, but I'm doing a half a sphere, so I'm going to need to multiply that by 1/2. I've marked it up a little bit, but the r for both of these is going to be 39. The unfortunate thing is the 81 is not the height. This 81 goes from the very top of the cone to the very bottom of the sphere. It passes right through the center, and the tricky part to this is to know that this part right here, the distance from the center of the sphere, half sphere, to the bottom of the sphere is 39. So of this 81 feet, 39 of it is from the sphere, and the difference between the 81 and the 39 is the height. The height is actually going to be 42. So what happens is this 81 feet is broken up into two segments. You have 42 feet from the top of the cone to the start of the sphere, and then 39 more feet inside the sphere. So the 81 feet is broken up into two different pieces, and I only need the 42 part. The height for yours is going to be the 42 feet. So when I go to find the volume of the cone, I'm going to say volume is going to be 1/3 times pi times 39 squared times 42. When I go to do the sphere, I'm going to say volume is going to be 1/2 times 4/3, this should be pi r cubed here, times pi times 39 cubed. And as I read through my instructions, write your answer as a fraction in terms of pi. So the volume of my cone is going to have a pi in it. Technically, it's going to have something feet cubed. My volume of my sphere is going to have a pi in it, and it's also going to have a feet cubed. Let me do your cone first. For the cone, I'm going to do parentheses 1 divided by 3, and then parentheses 39 squared, and then parentheses 42. This is going to come out to a big number, but a nice number. So it's going to be 21294 pi feet cubed. Wowzers, that's a big number. The sphere, I'm going to do a half a sphere, so 1/2, and then times 4/3 times 39 cubed. Oh, I get another nice number. Wow. So I get 39,546 pi feet cubed. And now I need to add these together to get the combined volume. So the answer is going to have a big number. It's going to have pi feet cubed, and I need to add 21,294 plus 39,546. So let me just do that real quickly here. So 21,294 plus 39,546. So I had to add the two volumes together, and I get 60840 as the number part. The pi and the feet cubed part stay alone, and they don't change. This is exactly what I had written for 23. 60,840 pi cubic feet is my volume. '25 and 26 are kind of silos in some sense. They're really exactly the same shape, although your bottom part is kind of scrunched on yours. So in order to do 26, similarly in order to do 25, I have to find the volume of the top, which is a cone, and I'm assuming this 3 centimeters on the bottom is still the same 3 centimeters on the top, and in my cone part on the top, the height is 4 centimeters and my radius is 3 centimeters. For your picture, your top is also a cone, and I'm assuming that that little dashed line is the radius and this dashed line is the height. So that's the top part of our drawings. The bottom part of our drawings is Coke can in some sense. And similarly, the bottom of yours is a Coke can, and that's a cylinder, and the volume formula for a cylinder is pi r squared h. So we're going to have two different volumes. I'll talk about the sides, the numbers here in a second. So the cone formula is volume is 1/3 pi r squared h. It's a full cone, so I don't need to multiply by a half. And the cylinder part, which is the base, the volume for it is pi r squared h. For my cylinder, it's easy to see the r and the h. For your cylinder, the r is still the same. The h is supposed to be this 2 centimeters. So for your cylinder part, this is another h. So we've got two different heights because the cone is taller than the cylinder. So let me do mine, and then you can do yours kind of simultaneously. And I was told to write my answer as a fraction and leave it in terms of pi. So first I'm going to work on the cone. I'm going to say the volume is 1/3 from the formula, pi from the formula. My r is going to be 3 squared. My h is going to be 4. I'm going to leave the pi there, and I'm going to get the numerical part for my cone. So for my cone, I'm going to do 1 divided by 3 times 3 squared times 4. The number that goes in front of my pi is a 12. Technically, it's cubic centimeters. I can save those units to the very end if I want to. So part of the answer, or part of the work that I need to get to my answer, is finding the volume of the top. I'm going to find the volume of the bottom and add them together. For my cylinder, I'm going to say the volume is pi. My cylinder, the r, is going to be a 3, and the h is going to be 8. So I'm going to do the 3 squared times 8. That's actually 72. So for the cylinder part of mine, it's going to be 72 pi, because 3 squared is 9 times 8 is 72. For the combined volume, or my answer, I'm just going to add the 12 pi cubic centimeters plus the 72 pi cubic centimeters. To do that, I just have to add the 12 and the 72, and I get 84. My answer is going to be the volume equals 84 is going to be the number. The pi needs to stay in my answer, and the units are going to be cubic centimeters. Your answer for 25 comes out to 150 pi cubic centimeters, even though it says, for mine, write my answer as a fraction. It wasn't a fraction. For 28 and 29, these are combined shapes. The top for our 27 and my 28 and your 27, this is a prism because I can look through it, and the base is a triangle. So the top, the roof, is a triangular prism. And I don't have that formula memorized, The volume is 1/2 times the base times the height times the length. So volume is 1/2 times the base times the height times the length. And then the bottom part of mine that bottom part's a rectangular prism. And the volume is the length times the width times the height. So let me go to the top first. The top's tricky. I need to do 1/2 the base times the height. The base times the height comes from the triangle, and this triangle right here has a height of 9, and its base travels up from there, which is 10. The length comes from the this part, and that's going to be that 8. So the numbers needed for just the roof part of this is those 3 numbers. So the volume of this is going to be 1/2 times the base, which is 10, times the height, which is 9, times the length, which is 8. So for my roof of this house type figure, I'm going to do 1 divided by 2 times 10 times 9 times 8, and I'm going to get the volume is 360. Technically, these lengths are supposed to be in feet, and it's supposed to be cubic feet. For the base, it's real easy, because for the base, it's a prism. I just have to multiply the 3 different numbers that I have highlighted in green here, the 10, the 8, and the 7. Technically, I'd probably, the side that has 2 sides, I'd call that the rectangle, make a length and the width, and the opposite side that only has 1, I'd call an H. But as long as you multiply those 3 numbers, you're going to get the volume just fine. My volume I'm going to get by finding 8 times 7 times 10, and that's going to be 560, because 8 times 7 is 56 times 10 is 560, and that's feet cubed. My answer, the total volume, I'm going to get by taking the 360 and adding it to the 560 and leaving my units cubic feet. So I get 920. Volume equals 920 feet cubed. For your problem, you have a triangular prism, and in the triangular prism, the height is going to be 8. The base, this doesn't print so well, is going to be 30. And then the length is going to be 50. So the dimensions you need for your triangular prism is 30, 8, and 50. For the rectangular prism base, the numbers you need are 35 and 12, and I'll let you kind of fiddle about and see if you can get the answer for 27 that I came up with, which was 24,000 cubic feet. Your drawing is better for 29 than mine is for 30. So it's another combined shape. Let me do the top, which is a funky looking triangular prism. It's a prism because, no it isn't. Yes it is. It's a triangular prism, it is. It's a prism because I could look through it. And it's a triangle because the base is a triangle. That's really bizarrely drawn. Yeah, that's definitely a funky looking triangular prism. So let me work on the top of yours real quickly. For the top, the volume for a triangular prism is 1/2 the base times the height times the length, and the base times the height comes from the triangle. The triangle here is 8 by 11. I'm going to call that the base and that the height. So part of the top, the triangular prism, I'm going to say the volume is 1/2 the base of the triangle, which is 8, the height of the triangle, which is 11, and then I need to toss in the length. The length is going to be that distance, which is 17. And let me do that in this calculator. So I'm going to do 1/2 times 8 times 11 times 17. The volume of the top is 748 cubic inches. Now I'm going to work on the bottom, and the bottom is just a lovely rectangular prism. And for rectangular prisms, I just multiply the three lengths that are given. So for the bottom, the formula for the volume of a rectangular prism is length times width times height. I usually take the length and the width from the side of the rectangle that has both sides labeled. I'm going to call that 8 a length, that 5 a width, and then the 17 is going to be a height. So I'm going to do 8 times 5 times 17 for the bottom and get 680. I need to add those together to get the combined volume. And 748 plus 680 is going to be 1428. My answer, the volume of that shape is going to be numerically 1428. Units, it's going to be cubic inches. And that's exactly what I got when I did 29. We just have 30 and 31 left. I generally don't put these on a test. Let me just do these real quickly. In fact, I think I'll just do yours with you. So in order to do our problem, unfortunately, I have to think of this as a box placed on top of a box. And what I'm going to do is I'm going to find the volume of this box, which is a rectangular prism, and add it to the volume of the bottom, which is also a rectangular prism. So for the top and the bottom, it's the same formula. The volume of a box like that is length times width times height. And I'm going to try to figure out the sides, but it's not going to be so easy. So for the top, I might have to do some subtracting, I may not. I need three lengths. This length right here is easy, that's 40 millimeters. This length right here, I'm going to assume comes up from that 10 millimeters, and it's going to be a 10. The other length that I'm going to need, so I've got that, and that, is one of these. So there's three different lengths here, and I've got the rectangular side here that's 40 by 10. I need to get something on the top. And unfortunately, to get that, I have to subtract. The distance all the way across this line that's kind of pink and blue is 60. The line below it is 80. The difference between this 60 and that 80 is this 20. This whole length right here is 80. 60 of it are already taken up. 20 of it's the rest of it. I took this 80 minus that 60 to get the rest, the other part of my box. So for the top, the three lengths are 10, 40, and 20 that I need to multiply together. For the bottom, the numbers I'm going to need to multiply together are this 80, and then I'm going to need to get two more numbers. One of them is going to be this 10. I'm also going to need to get this side right here, and unfortunately, I don't know that's this length. This whole length right here is 60, and this part of it from here to here is 40. So I'm going to break this 60 up, this whole 60, into the 40 that's from here, and then this bottom part, which is another 20. So this whole 60 breaks up into 40 from the top, and then an extra 20 from the bottom. So this piece over here is going to be 20. The three dimensions I need for the bottom, I don't think this was my best explanation ever, but I won't sneak this on the test because it's not my best explanation. I'm just maybe kind of anxious to be done. So the bottom is going to be 80 times 10 times 20. Let me figure out the volumes of each and then add them together. So 10 times 40 times 20 for the top, which is 8,000 cubic millimeters, and the bottom 80 times 10 times 20, which is 16,000 cubic millimeters. And then I'm going to add these together. And 16,000 plus 8,000 is 24,000. I have an extra 0 there. So the answer is what I'm going to get when I add the 8,000 plus the 16,000, and that's going to be 24,000. And the units are going to be cubic something, and in my drawing the units are in millimeters, so I'm going to say the volume is 24,000 cubic millimeters. This is pushing right on an hour, and that's kind of the maximum that I like the videos to be. So I'll stop now. If you're not feeling comfortable with these combined shapes, let me know, and I'll kind of work through them with you in class.